Isobaric process is a constant pressure process. We want to find an expression for the work done in an isobaric process. Consider a gas in a cylinder of cross-sectional area A and fitted with a movable piston. The pressure of a gas results a force that displaces the piston upward by a displacement dx. Thus, force F is equal to pressure into area A. Here, A dx expresses volume increase dV due to small piston displacement dx. The work done by the gas dW for infinitesimally small volume changes is equal to force dot displacement dx. As F is equal to PA, therefore dW is equal to P into area into dx, which becomes equal to PdV. Work done for finite volume changes can be obtained by integrating this PdV for initial volume V1 to final volume V2. Because isobaric process has a constant pressure, therefore P is taken as constant and therefore it is taken out of the integral. After solving this equation, the expression for work done is equal to P into V2 minus V1, or it is equal to PdV. Now this expression can be used for isobaric process to evaluate the work done during isobaric expansion or isobaric compression. In isobaric expansion, the final state appears with higher volume V2 than the initial volume V1. That's why W, work done by the system or the gas, is positive because heat enters from the bottom of the cylinder, therefore it is positive. According to ideal gas equation, PV is equal to nRT. Because N and R are fixed, temperature must increase as the volume increases so that pressure of the system or gas remains constant. According to first law of thermodynamics, heat Q being entered into the system and W, work done by the system, are both taken as positive. Therefore, change in internal energy del U is positive or greater than 0. This means that internal energy of the final state U2 is higher than the internal energy of the initial state U1. Due to this, temperature of final state T2 becomes higher than the temperature of the initial state T1. Hence, temperature increases during isobaric expansion. In isobaric compression, volume of the final state V2 will be less than the volume of the initial state V1. Therefore, from this equation, the work done has negative sign because in compression, piston is externally pushed down, which results the heat flow out of the gas or the system towards the surroundings. Therefore, this heat Q is taken as negative. According to ideal gas equation, PV is equal to nRT. If N and R are fixed, temperature must decrease as the volume decreases so that pressure can be kept constant. According to first law of thermodynamics, heat leaving the system and work done on the system are both taken as negative. Therefore, change in internal energy del U is less than 0 or del U is negative. Thus, final state internal energy U2 is lower as compared to the initial state internal energy U1. Due to this internal energy and hence the temperature decrease after isobaric compression. In summary, we can say that in isobaric process, temperature in the expanded state increases, but in the compressed state, temperature decreases.